about the double videos, guys. There was just no way I could fit everything we needed to do as far as vocabulary notes and the examples for solving equations. It's such a huge topic and a huge part of algebra. So I know I say that every time, but it's true. So let's go ahead and get straight to some examples. All right, so let's use that to do some examples. 3x equals 15. I know that you can probably look at that and know what the answer is right away, but I'm still going to go through the steps. What I see here is multiplication. If I want to undo multiplication, then I have to use its inverse operation, which is division. I'm going to divide on both sides by 3. I can do that because I have the division property of equality. That's what allows me to be able to divide on both sides and maintain the equality or the balancedness of this equation. So 3 divided by 3 is 1. I know that 3 divided by 3 is 1 because of our inverse property that we learned in Unit 1. The inverse property says 3 divided by 3 gives me 1, and I have 1x equals 15. 1 times x, oops, sorry, it doesn't equal 15. It equals 5. 1 times x equals x. We know that because of the identity property that we learned a long time ago, back in Unit 1. And that leaves me with an answer of x equals 5. And I get to box that in and move on. All right, example 2, solve for n. I see division here. In order to undo division, I'm going to use the inverse, which is to multiply. Multiplying by 14, I'm going to multiply by 14 on both sides. That's the multiplication property of equality. 14 over 14 gives me 1. That is my inverse property, my multiplicative inverse property. And then over here I have 2 times 14, which is 28. And then 1 times n is equal to n. That's my identity property of multiplication. And I have an answer of n equals 28. Obviously, not every equation can be done in just one step. So we're going to look at some two-step equations now. When you are trying to solve a two-step equation, you're going to first identify what operations are being done, just like we did in the one-step equations, and then use the inverse of each operation to undo it. Since you're kind of working backwards to try and get this variable by itself, you will usually, not always, but usually find that you're kind of going through those order of operations in reverse. So instead of grouping symbols first, or instead of always doing your multiplication before your subtraction, you're going to be kind of going at it from the bottom of our order of operations, dealing with any addition or subtraction, then going up to multiplication and division, then exponents. So let me show you what I mean by that. When I see this, 3x plus 4 equals 14, I kind of think of this as my little couple that I need to keep together, and I got to get rid of this 4 that's out here to the side. Because this is adding 4, I'm going to undo it with subtraction. Because of my subtraction property of equality, I have to subtract 4 on both sides. That leaves me with 3x, 4 minus 4 is 0, and 14 minus 4 is 10. Now, remember that you've kind of got a dividing line, and this is where we're doing everything on both sides. This 4 and negative 4 being 0 is a result of our inverse property of addition. That's the property that we use there. And then 3x plus 0 is just 3x. That is a result of my identity property of addition. Right? Now I see multiplication, so I'm going to do division. I'm going to switch to a different color so you can see that I'm kind of at a different step now. When I divide by 3, I have to divide by 3 on both sides of my equation. That is because of my division property of equality. And 3 divided by 3 gives me 1. That's my inverse property of multiplication. And 10 divided by 3 gives me a decimal, and I didn't bring a calculator out here, but I believe it is 3.3 repeating, or 3 1/3. And I'm okay with that. Getting a decimal is not a big deal. 1 times x is x. Please excuse my phone. 1 times x is x. That is a result of my identity property of multiplication. And 3.3 repeating, or 3 3/10 repeating, is still there. So this is my final answer. All right. I've been showing you these steps just to kind of show you that although we don't usually show our reason for every single, this is kind of an informal algebraic proof. I'm explaining why I'm able to do every step. You obviously won't always show this 3x plus 0, and you won't always show this 1 times x. You'll just know that 4 minus 4 is 0, and adding 0 isn't going to change anything. But for the introductory part, just kind of showing you how that works, I'm showing those steps. So I'm going to start to kind of take away some of those steps now as we get into this fourth example. So what I see here looks kind of scary. We've got y plus 4 over this 3, and it equals 9. Now, way back in the order of operations lesson, I told my students that you have to kind of think of your fraction bar as a grouping symbol. There's kind of understood parentheses there. What I like to say is, if you see this division by 3, this giant fraction, that's what's causing us strife. When we look at this, we get angsty, we get scared because of that fraction. So if the fraction is what's bothering you, then get rid of the fraction first. That is division, and if I see division, then my inverse would be multiplication. If I multiply by 3 over here, then I'm going to multiply by 3 over here. 3 times this fraction of 1/3 cancels, becomes 1 times y plus 4, because 3 divided by 3 is 1. Over here I have 9 times 3. Remember that I'm kind of dividing it right here. Over here I have 9 times 3, which is 27. And 1 times y plus 4, because of the identity property of multiplication, I'm not going to write that, but we know that that's just going to equal y plus 4. Even if you went through the trouble of distributing that, 1 times y is just y, 1 times 4 is just 4. So we're left with y equals 4. Y plus 4 equals 27. And now I have some addition that I've got to undo. Undoing addition requires us to use subtraction. That's my subtraction property of equality. And when I subtract 4 minus 4, I get 0. 0 plus y is just y. And 27 minus 4 is 23. And there's my answer. So I kind of skipped some of those steps. I still showed my 1 here. I wouldn't normally do that, but I wanted to show you kind of what was happening with those 3's. So if you have any more trouble or questions, please let us know, and we will get to some practice. There is both practice and application for this lesson, so please make sure you look at those application problems, because this unit is going to be really heavy on word problems. All right, see you in a little while.